Hi, my name is Koen Beyers. I'm founder of Voxdale. Voxdale is a design and engineering agency for new products and services. I've been a technology addict all my life. I worked for Barco in the mechanical design lab. I worked in Jaguar in F1. And it was there that I got addicted to simulation, to finite element analysis and to CFD. In that design process, we use a lot of simulation and optimization tools. When we started the company, we had to decide on CAD and CFD tools. Keeping in mind that time to market has to decrease and that you need flexibility to check different variants and to optimize before you start building prototypes, we decided to work with FLOEFD from Mentor Graphics. In fact, we've been using that, I think, since 11 years. It was FLOEFD 6 at the time. And over the years, we've seen evolving the tool in functionality, in size, in speed. And it's great to use these kind of tools to have early feasibility and risk mitigation at the start of a project. Customers expect us to take risks, and we can take these risks in these simulation models. One of the main challenges we have in our EFD work is the validation of our results. And that's why we participated in the Flanders Bike Valley wind tunnel project. So this is a very early mock-up of the Flanders Bike wind tunnel and the building. You have to come up with a design and then you have to take the step to really build it. And that's where we stepped in with FLOEFD. So we modeled the contraction section, we modeled the test section, the diffuser, but we also modeled the hull around it. As it is an open return wind tunnel, we had to simulate and visualize the flow back from the fans towards the contraction section. And that gave us enough confidence to validate the design of the tunnel itself and to have the correct dimensions of the hull. We are here today in the facilities, brand new facilities, so let me show you around. So here we are in the wind tunnel hull. Voxdale was highly involved in the design of the tunnel, both aerodynamically in FLOEFD, but also structural and architectural. When designing a wind tunnel like this, a lot of decisions have to be made. The size, the performance, the speed, the type of wind tunnel, but also budget-wise, it's a complex exercise. So when all design and aero decisions were made, we came up with this unique object. We're very proud of it. It's an open return, low-speed wind tunnel. It's about 50 meters long, 600 square meters of surface. Here you can see that the contraction section, it's 8 meters in diameter. It guides the flow laminar towards the test section. The test section is 2.5 meter diameter, 6.5 meter long, and it ends up in the diffuser section leading to the fan. Next to the calibration of the tunnel, which is going on as we speak, we are working on a digital replica of the test section in FLOEFD. Having a virtual test section like that will facilitate the preparation of the wind tunnel use. After that, we can use the correlated results of FLOEFD compared to the wind tunnel test to further develop in FLOEFD. Welcome to the sacred place. We are now inside the test section of the wind tunnel. 2.5 by 2.5 meter in section and 6.5 meter long. At the rear end, you see these 4 huge fans. At the other side, you will see the contraction section. Here we have the interface plate of the load cell. It's now equipped with a bike, but for instance, we are working on a new bobsled for the Pyongyang Olympics in 2018. On the right-hand side, you see the green screen. That is used for the PIV system, of which you can see the laser at the left-hand side. So this laser casts a sheet of light into the test section, and the camera on top will then take the EFD-like pictures of the velocity and the flow direction. It's a real thrill to be able to stand in this test section. We are really proud of this project, and it's almost unbelievable what we have materialized in this short period of time to end up with this F1-like facility.